Welcome to Calculations Using Exponential Notation. So, in chemistry, most of the processes we study are based on simple whole number ratios. And research on how we think, how our brains work, shows that if we can do simple calculations based on mental arithmetic, rather than using a calculator, it frees our brains for other tasks needed for problem solving. So, don't use your calculator. Use your brain. We also need ways of checking calculated answers to be sure that they're reasonable. So, you should always check the answer that you get using your calculator against an estimate that you make to be sure that they're close. They don't have to be exactly the same, but they should be close. If you're off by a lot, if you have a decimal point in a different place than it should be in your two answers, then there's probably something wrong. You need to go back and check your work. So in this section, we're going to review the rules for solving exponential calculations in your head. So recite these rules until you can recall them from memory, and then periodically return to check if you can recall them, as you're going to need to know them throughout your whole chemistry career. So when you multiply exponentials, you add the exponents. So 10 to the 3 times 10 to the 2 equals 10 to the 5. So we're multiplying 10 to the 3 times 10 to the 2. We add together the exponents. 3 plus 2 is 5. So our answer is 10 to the 5. 10 to the minus 5 times 10 to the minus 2 means we add together the exponents. Negative 5 plus negative 2 is negative 7. So our answer is 10 to the minus 7. 10 to the minus 3 times 10 to the 5 is negative 3 plus 5. That's 2. So our answer is 10 to the 2. When we divide exponentials, then you subtract the exponents. So if we have 10 to the 3 divided by 10 to the 2, we're subtracting, so 3 minus 2 is 1. So our answer there is 10 to the 1. And this works because 10 to the 3 is 1,000, 10 to the 2 is 100, so 1,000 divided by 100 is 10, that's 10 to the 1. So it works. 10 to the minus 5 divided by 10 to the 2, we have negative 5 minus 2, that gives us negative 7. So our answer there is 10 to the minus 7. 10 to the negative 5 divided by 10 to the negative 2 is 10 to the negative 3. And remember here that minus a minus is a plus, so negative 5 minus negative 2, or minus minus, so that's plus. So negative 5 minus negative 2 is really negative 5 plus 2. Negative 5 plus 2 is negative 3, so our answer there is 10 to the minus 3. If we have 10 to the 6 divided by 10 to the minus 3, then we have 10 to the 6 minus negative 3. 6 minus negative 3 is really 6 plus 3. 6 plus 3 is 9, so our answer there is 10 to the 9. So you should be able to do these sorts of calculations in your head without needing a calculator. When you take the reciprocal of an exponential, then you change the exponent's sign. Not the exponential sign, the exponent's sign. So you're not changing the number in front of the 10, you're not changing the sign in front of the 10, you're changing the sign in the exponent of the power of the 10. So, in other words, when you move an exponential term in a fraction from the bottom to the top, or vice versa, then we change its sign. So 1 divided by 10 to the 3 is equal to 10 to the negative 3. 1 divided by 10 to the negative 5 is equal to 10 to the positive 5. So, why does this work? Remember that dividing by an exponential terms means you subtract the exponents. So if we have 1 divided by 10 to the 3, remember that 1 can be written as 10 to the 0. Well, that means that we have 10 to the 0 divided by 10 to the 3. So if we subtract the exponents, we have 10 to the power of 0 minus 3. 0 minus 3 is negative 3, so 10 to the minus 3. For any x, if we have 1 divided by the quantity 1 over x, that's just equal to x. But why? So why is this true? Well, we can say that 1 over x is equal to x to the minus 1, which means that 1 over x is 1 over x to the minus 1. And that just means that we can say that this fraction is the denominator to the minus 1. The denominator in that case is x to the minus 1. So we now have x to the minus 1 to the minus 1. And if we have an exponential term to a power, then we multiply the exponents. So 1 over the quantity 1 over x is equal to 1 over the quantity x to the negative 1. And that's equal to the quantity x to the minus 1 to the minus 1. And that means that now we're going to multiply the exponents. So x to the negative 1 times negative 1. Negative 1 times negative 1 is positive 1. So that is equal to x. So whatever x is. So we can say x is 2 or 7 or whatever. So if a fraction contains several terms, then we're going to simplify the top and the bottom, the numerator and denominator, separately, and then we'll divide. So if we have 10 to the minus 3 divided by 10 to the 5 times 10 to the negative 2, we're going to simplify the top and the bottom. The top is already simplified, but the bottom can be simplified. So we have this product here, 10 to the 5 times 10 to the minus 2. We know that when we're multiplying, we need to add together the exponents. So 5 plus negative 2 is positive 3. So now we have 10 to the minus 3 divided by 10 to the positive 3. And now when we divide, we need to subtract the bottom one from the top one. So 10 to the minus 3 minus 3. Negative 3 minus 3 is negative 6. So our answer there is 10 to the minus 6. Let's talk about practicing. You should do as many practice problems as necessary until you feel that you're ready for the quiz. If you're not confident about taking the quiz and know that you're going to get an A on it, then you need to do more practice. It's up to you to be able to determine whether or not you need to do more practice or not. So, you should practice writing and recalling the new rules from memory before starting any practice problems. If you use the practice problems to try to learn the rules, then you're going to end up needing to do a lot more practice problems, which is going to take you a lot more time than if you had memorized the rules and then practiced. On the other hand, if you already know the rules and only use the practice problems to apply the rules that you've already learned, then you'll need to do fewer of the practice problems in order to feel ready for the quiz. So that's what you should do. You should memorize the rules and then, and only then, do the practice problems. You need to continue doing practice problems until you feel ready for the quiz. If you feel ready for a quiz and then you take a quiz and you don't do so well, then you know that in the future you have to do more practice problems. You need to tune where your threshold is for feeling ready for the quiz. Also, if you don't do as well on a quiz, you need to go back and refresh your memory on that material so that you don't say, oh well, I didn't do so well, and move on, because then you still haven't learned it, and that's going to come back and haunt you, because in chemistry, just about everything builds on the previous material. Now let's talk about multiplying and dividing in exponential notation. So when we're multiplying and dividing in exponential notation, you're going to handle the coefficients and exponents separately. That is, you're going to do the number math using number rules, and you're going to do the exponential math using the exponential rules, and then you're going to combine the two parts. Let's look at a couple of examples. If we have 2 times 10 to the 3 times 3 times 10 to the 2, we're going to separate out our coefficients and our exponents. So the coefficients are 2 and 3. They're being multiplied here, so 2 times 3 becomes the coefficient portion. And then the exponential portion is 10 to the 3 times 10 to the 2. So we have 10 to the 3 times 10 to the 2. Well, you should, in your head, be able to do 2 times 3 is equal to 6. And 10 to the 3 times 10 to the 2, that's 10 to the 5, because that's 10 to the 3 plus 2. And so now we have 6 times 10 to the 5. So you should be able to do a calculation like this in your head. You shouldn't need a calculator. You're welcome to check using a calculator, but you should always be able to do this first in your head, and then when you do it on the calculator, if your calculator agrees with you, then you probably have the right answer. If your calculator disagrees with you, then you need to go back and do the math again in your head and do it again on the calculator using a different set of buttons, if possible. So let's look at another example. 2 times 10 to the 3 divided by 3 times 10 to the 2. So again, let's separate out the coefficient math and the exponential math. So we have coefficients of 2 and 3. So we have 2 divided by 3. And we have then the exponential terms, 10 to the 3 divided by 10 to the 2. So we have 10 to the 3 over 10 to the 2. Well, 2 over 3 is 2/3, so that's 0.66 repeating. 10 to the 3 over 10 to the 2, that's 1,000 divided by 100. That should be 10. But we also know exponential math, that's 10 to the 3 minus 2. 3 minus 2 is 1, so that's 10 to the 1. So our answer there is 0.66 repeating. That's what this line over the top of the 6 means. It means that that 6 keeps going. We keep repeating it. So 0.6 repeating times 10 to the 1. But then we have to write our answer here in proper scientific notation because we can't start with a 0. So we need to move the decimal point one place to the right, which makes the coefficient bigger. That means we need to make the exponential term smaller. So that gives us 6.6 times 10 to the 0. Because we had 10 to the 1, we made the coefficient larger by 1 decimal point. That means we need to lower our power, our exponent here, by 1. So from 1 to 0. And then times 10 to the 0 is just times 1, so we can drop that part. So our answer then becomes 6.6 repeating. So when we're dividing, if an exponential term does not have a coefficient, then we want to add 1 times in front of the exponential so that the number division is clear. So if we have 2 times 10 to the 3 divided by 10 to the 2, we're going to add a 1 times in front of that 10 to the 2. So now we have 2 times 10 to the 3 over 1 times 10 to the 2. And that means that now our number division is 2 over 1, which is 2. And our exponential division is 10 to the 3 over 10 to the 2, which is the 10 to the 1, just like in the last example. So now we have 2 times 10 to the 1, that's 20. So when you can't do the coefficient math in your head, then you can use a calculator for the coefficient math, but you still should not be using a calculator for the exponential math portion. So in your notebook, write a list of rules that we've covered in this section, and add these rules to your list of rules from section 1.1. Then write and recite this list until you can write all of the rules, both from this section 1.2 and from the last section 1.1 from memory. And you should have all of these memorized. You should be able to write them out from memory without having to refer to your notes or your book. And then, and only then, once you've memorized all of them, then do the practice problems from the book. And this way you won't have to do as many practice problems. So that was calculations using exponential notation.